All right, welcome to day 8. Remember, we decided not to do the homework for day 7, so we don't have anything that we have to do for going over homework. Today is something, it's not really going to be new. We just haven't done it in a little while, so we'll refresh on that. Page 20 will be your homework. On page 20, you need to fill out the entire tables to get the credit, not just the equation. And you'll see what I'm talking about with that when we do our first couple problems. So we're going to start on page 18. And we want to find the equation for this table, but we don't know if it's linear or exponential. So what we had done when we saw these before, we did our change in y over change in x in this column, and we did our successive ratios in that column. We always blocked out the first one because we didn't have the point before. And let's do our change in y over change in x column. So we got to do y minus y over x minus x. So we'll do 1 minus a negative 1. So we did this 1 minus that 1 over 1 minus 0. Well, minus a minus gives us a plus, so that'll give us 2 over 1, which is just 2. Next, we'll do 3 minus 1 over 2 minus 1. So that's 2 over 1, which is just 2. Next, we'll do 5 over 3 minus 2, which should give us 2. And if we keep going, we're going to find that it is 2 each time. So our successive ratio, we're always doing y2 divided by y1. So we're going to do this y divided by the y before it. So 1 divided by negative 1 is negative 1. So now for the next box, we'll do this y divided by the one before it. So 3 divided by 1 is 3. Next, we have 5 divided by 3, which doesn't reduce, so we'll just leave it. 7 divided by 5, 9 divided by 7, and 11 divided by 9. What we had found a couple units ago was if the slopes were constant, then we are working with linear. And if the successive ratios were constant, then we were working with exponential. So this tells us we have linear, y equals mx plus b. So our m is just what we got for the slopes. So we have y equals 2x. And then your b is the y value that corresponds when x is 0. So our b value in this case will just be negative 1. So on your homework, if you get one of these on your test, you will have to have the table completely filled out. Okay, even though we saw it was going to be linear after having 2's in the first column, still got to fill out the successive ratio column to practice that. We are not going to do question 2 or 4 on this page, so we're going to go and look at just 3 next. So we'll do our change in y over change in x and our successive ratio, and we'll block out the first 2 boxes. So we're going to do y minus y over x minus x. So y minus a half, doing that minus that, over 1 minus 0. 1 minus a half gives us a half. Next we'll do 2 minus 1 over 2 minus 1. So that'll give us 1 over 1, which is 1. Next we'll do 4 minus 2 over 3 minus 2. That'll give us 2 over 1, which is 2. If we keep going, 8 minus 4 over 4 minus 3 will give us 4 over 1, which is 4. We'll have 16 minus 8 over 5 minus 4. So that's 8 over 1, which is 8. And to finish out, 32 minus 16 over 6 minus 5, which will give us 16 over 1, which is 16. So it looks like this is not going to be linear, so hopefully we'll get the successive ratios to be the same, and it'll be exponential. So we got to do y2 divided by y1. So we're going to have 1 divided by a half. Well, if you have a fraction within a fraction, we like to write that horizontally. Doing keep change flip, this will be 1 times 2 over 1. 2 over 1 is just 2, so we get 2. Next one, when we do a y divided by the one before it, 2 divided by 1 equals 2. Then we'll have 4 divided by 2 equals 2. 8 divided by 4 equals 2. 16 divided by 8 equals 2. And then 32 divided by 16 equals 2. So we've got our successive ratios are constant. That tells us we should be working with exponential. Exponential is in the form a times b raised to the x. Whatever you found as your successive ratio, that's your b value. And a, as long as there wasn't any asymptote somewhere else, a is just corresponding to when x is equal to 0, so we get a half. A half times 2 to the x. So what we just saw in these two problems is how you will do the homework. You will do the tables all the way out. When we look to the next page, both questions 5 and 6 tell us that we have a horizontal asymptote. If we have a horizontal asymptote, it's got to be exponential. So because that basically takes away from the mystery of whether it is linear or exponential, for these two particular ones, we're not going to do the table. We're going to treat it like we did on days 4, 5, and 6, where if you know it's exponential and you have 2 points, we'll just find the equation from those 2 points. So that's what we're going to do for 5 and 6. On the homework, we won't know if it's linear or exponential, so you got to do the entire table. But again, because they told us we have an asymptote here, it means we're going to be in the form y equals a times b to the x. And because we have a horizontal asymptote at +1, we'll just have a +1 on the end. Here's our x's and y's that we will sub in. So we'll have 4 equals a times b to the 0 plus 1. And 7 equals a times b to the first plus 1. Subtract your 1's over in each case, and we'll get 3 equals a times b to the 0. And 6 equals a times b to the first. Divide your equations with the one with the bigger exponent going on top. So we'll have 6 over 3 equals ab to the first over ab to the 0. 6 divided by 3 is 2. The a's divide out. And when you subtract your exponents, you just get b to the first, which is b. We'll sub back in to find what a is. If you've got a b raised to the 0, sub in there, it'll be easier. Anything to the 0 is 1, so this is a times 1, so a is just 3. Write it out, y equals 3 times 2 to the x, and don't forget your +1 on the end from our asymptote. So one last one. For this video. Again, we know this was exponential because of the asymptote, so we'll start out with the form a times b to the x plus 5. We'll use these 2 points here. So we're going to have 6 equals a times b to the 0 plus 5, and 5.5 equals a times b to the first plus 5. Subtract the 5's over. We'll get 1 equals a times b to the 0. And we'll have 0.5 equals a times b to the first. Bigger exponent is the 1, so that will go on top. 0.5 divided by 1 is equal to ab to the first over ab to the 0. Anything divided by 1 is itself, so we get 0.5, or you could write it as a half if you wanted. The a's divide out. When you subtract your exponents, we just get b to the first. So b is 0.5. Probably want to sub it back in this one so you can work with b raised to the 0. Anything to the 0 is 1, so we just get a equals 1. So we could write it as y equals 1 times 0.5 to the x. And then we have that plus 5 on the end. Because multiplying by 1 doesn't do anything, if you didn't have times 1 out front, that would be fine as well. So a reminder, to get credit for the homework, you need to have the charts filled out like we did on the previous page. Once you have the charts filled out, that'll tell you if it's linear or exponential, and you can use the ones we did on page 18, 1 and 3 to help guide you of how to find those equations. Have a great rest of your day, and you got page 20 for homework.